and the circuit were RC circuit and LR circuit, right? So for both of these circuits, we calculated the decay for the going current. Okay, so in what part we get the decaying current and in what part do we get the going current? Do you remember that? In what circuit we get going current? Yes. What circuit we get going current? In what circuit we get decaying current? Remember that? Sorry. Yeah. So, hello Tarif, can you hear me? Yes, Tarif, are you there?
Yes, same here.
Yeah. So I was asking that in what circuit you get the decaying current, and in what circuit you get the going or increasing current. Uh, Sure. So in inductive circuit, we get the going current, right?
Yes.
I was I naught 1 minus power RD minus, right? And then in capacitive circuit, we get the decreasing decaying, right? So I was I naught e to the power minus of d by R, right? That is why we get decaying current in this capacitive circuit, and in inductive circuit we get decay. So now the next topic is transform, right? So in transformer, what do we have? We have two circuits, right? One is like, this is input, right? And then this is the output that you take. And then this one is connected, right? So we have this, right? And then we have this thing which is connected to the one. And then we have another thing, right? This is connected to the so and so there are two things, right? One is the input part, right? Which is the primary thing, and then we have the output part, which is this circuit, right? Which is we can say primary coil and secondary, right? So in primary coil, what are the parameters involved? One is the voltage primary, and then we have this number of turns, right? Number of turns in primary coil, and then current in primary coil, and then power in primary, right? These are the parameters involved in the primary coil. Right. In the secondary coil, what are the parameters? We have voltage in secondary coil, we have number of turns in secondary coil, and then current in the secondary coil, and then power in the right. So these are the parameters that define the primary and the secondary coil. And then we know that because this is the input that we are providing. So what would be the EMF that would be generated? EMF that is generated in primary coil would be what? That would be minus of NP and d phi by dt from the Faraday's law, right? Right? And then we have this secondary coil as well. So in secondary coil, that would be how much? That would be ns d phi by dt. Right? If we divide these two things, So what we will get? We will get P by Vs, that is equal to NP by N. Right? This is the thing that we get and transform. Right, Tariq?
Yes, sir.
So let's say, so there are you have learned about two kinds of transform, right? So we know that the voltage in primary and secondary coil, that is dependent upon the number of turns. So if, let's say, if I want to increase the voltage, Shavid, Shavid. Okay, so what do we get? So we have, let me write, there are two kinds of transformer. One is the stepper transformer, right? So we know that what would be a step-up transformer? We know that the voltage in secondary coil and divided by this is equal to Ns by N, right? So if I increase the number of turns in the secondary coil, right? If Ns is greater than, yes, walaikum salam, Shave, yes, yeah. So we have just started transformer, right? We have just started transformer and yeah, we're talking about this. So if I increase the amount of turns in the secondary coil, right? So if I take this thing in this side, so what would be there? If I take this NP in this side, so what would be in here? Yeah, what would be? So if I take this thing in the left hand side, what would be the let's say if you have x equals to something y, if you take this y in the left hand side, so what is remaining in here? It- Yeah, so that would be 1, right? There would be 1, right? So there would be 1 in here. So similarly, if I increase the number of turns in the secondary coil, right? So this ns by np would be greater than 1. If I put this value in here, what I will get? I will get this is greater than 1, so which means that the secondary voltage. So voltage in the secondary coil that has been increased, right? So that would be called step-up transform. Why? Because if I increase NS, right? So then simultaneously I get, so when I increase the voltage in the secondary coil, so that is called the step-up transform, right? And I know that, let's say I transfer full power to the secondary coil. So power, right? Power input, that is equal to power out, right? So the whole power is being transferred to this is the whole power is transferred. So this would be called 100% efficient transform. So if efficiency is 100%, then the whatever power I'm supplying, so I'll be getting the same power in the output, 100% efficient transform. So I know that V input would be how much? That would be VP, IP, and this is equal to VS IN, right? So then this VS by VP, that would be equal to how much? So that would be IP by IS, right? So if I have increased, so I know that IP by IS would be how much? That would be VS by V, right? And I know that this thing is greater than 1 for a step up, right? IP and by IS. that is greater than 1, which means that the current in primary coil that is greater than secondary. So current is decreased, voltage increased by right voltage increased and current decreased. So this is your step up transform, right? So this is your step up transformer, and similarly, I will write directly it as well. So step down is what you uh, decrease the number of turns, right? How did you get this inequality? Oh, and this is yeah. So what part you are saying? This thing, Chavez, are you asking about this thing? Yeah. So you see that for step up, we got this result, right? This result we already got. Yes, by VP for step up, we got this result. Right. So I have just put this value in here, and this result I have got from here because this result I already. This is the result I already, and this is I get from Faraday's law. So from Faraday's law, the change in flux that would create an EMF, right? And change in secondary coil in the flux due to change in the secondary coil that would create the voltage in the secondary, right? If I divide these two, so I'll get this. So the voltage in both the coils are related by this number of turns. And this is how if I increase, so this is my initial condition. I increase the number of turns in the secondary coil, so then I will get this voltage in the secondary coil that would be increased. So that is why I'm calling it step-up transform. So I am increasing the voltage in the secondary coil. So let's say if I am getting 440 volt voltage supply, and I increase it to let's say 2000 volt. So then that would be a step-up transform, right? By just increasing the number of turns. And from this result, I got from the power relation, right? From the power relation, I will get this inequality. Or, yeah. So is it clear? Is it clear now, Shavi? Is it clear? Yeah. And similarly, we'll get the same result for this step down transform. So we will get voltage that would be less than primary coil and current that would be greater than primary. This would be, I will not write because the exact same thing is happening. So this is step down, right? So step down transform. But these are ideal cases, right? These are ideal cases. It may happen that you can have some flux leakage, right? You can have flux leakage, and this thing is different for this thing. These two things may be different, and then you will get another thing. So that is called the efficiency. Flux leakage, right? You have the efficiency. It is the efficiency of transform, right? So this is what this is denoted by eta, and this is equal to power output. Whatever output you are getting divided by whatever you supplied. This is VSIS divided by I, right? And if I want to calculate the percentage efficiency would be just this thing multiplied by this is the percentage. Okay, so these are the things that we have to remember in transfer. And do we have anything else? I guess we have. Please note it down and then we'll do some questions. Uh, Please note it down very and then we'll do some questions. Uh, yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys want me to scroll down, basically.
The
Yeah,
VP by VS is a transformation ratio.
yeah, VP by VA is the ratio of the voltage, right? Yes. VP by VS is what? This is the voltage of ratio of the voltage, right?
Yes, it's a transformation ratio, right?
Transformation ratio. What do you mean by transformation ratio? If yeah, so it is seen in this way that how much voltage you are getting in the secondary coil, right? So if there is so no flux leakage, right? So then yeah, this is the transformation ratio. In that sense, you can say that yeah, what would be the voltage in the secondary coil? That is
And support transformers will take a higher current
yes.
and directly be DC to AC, right?
No, no, no. So transformer doesn't change the AC current to DC current, right? That is rectifiers. Transformer doesn't. So it will you will get another you will get AC current, right? Transformer you will get AC current because the supply is AC. Then you will get the AC current, you will get, right, from transformers. And then you connect these transformers, right? So the current that we are getting, right? So let's say at some power station, the from generators, you are getting some 11,000 or 33,000 voltage supply, right? And then there are transformers at a particular area. So from power station, we use the step down transformer at each different blocks. And then from transformers, we are getting the household supply, right? So those are step down transformers. And those whatever 33,000 or 11,000 voltage supply that we get, that is transformed into what value? What is the value that you get from transformers? Do you remember that? What is the household supply that you get? Yes, sorry. What is the household supply that you get? Chavez?
100 volt.
Yes, yes.
There will be 100 volt or something, right? At least 100.
220, 220,
Yeah, 220.
20 and 50 hertz, right? So this 50 hertz is what? That an AC supply or DC supply? So that is an AC supply, right? So from transformers, we get AC supply, right? In household circuits, we get AC supply, and then from different devices, let's say some rectifiers, some filters, let's say from rectifiers and then band pass filters, then we change it to the DC supply, right? But from transformers, we'll get the AC supply. Is it clear? Is it clear, Tari? Yes, is it clear? Yes, Tari, is it clear?
Yes, okay.
Then we down this part, right? And then we'll do some.
1 minute, can you scroll up?
Oh, so you in semiconductor devices, guys have done this, right? Let's say this is then let's say that you are uh, have this food uh, right, or, right. So in this supply, in this load, what kind of supply that you get, right? Let's say this transform, right? And then this is the supply that you get. Part is connected to this part. This part is connected. So you get an AC supply, right? And then at this part is changed. Right? So this is the full wave rectifier, right? And in half wave rectifier, this part is not there. In half wave, we have this thing, right? And then we connect a filter. Let's say we connect a capacitor to this circuit. So then this part is there, and then we get this kind of, right? So then we get a DC.
So can you scroll down?
This is quickly note down this part, and then we'll do some questions. Whenever you guys have written, please. Yes, whenever you guys have written, yes, whenever you guys have noted, please tell me. Done, guys, noted. Yes, noted, everyone.
So
Whenever you have noted, please tell me. We step down what we are doing, are increasing the voltage and decreasing the voltage and increasing the current. That is the step.
yes, sir.
Yeah. Okay, so then, and you can also see that if, right, if efficiency is 1, right? So if there is no flux leakage, so efficiency is 1, right? Efficiency is 1, then yes, IS is that. This you can see from. So let us do some questions. voltage is given, right? What are the things which are given? So you are given voltage primary, that is 220 volt, right? And then I primary, don't know, right? So I primary, and also what is given? I secondary. This is 0.11, and power secondary. This is given 60. Right. They are asking that what kind of transformer is there? What kind of transformer is there? So from these two things, right, we can calculate what is Vs. So Vs would be Vs by Is. Right. So how much is this? 60 divided by 0.1. This is upstairs. Right. So this is 6,000 by 11. This is 5. And then 50. So this is 4. 44 and then 5. Right. Point something. Times. Okay, again, we get right. So this much voltage is the secondary. What kind of transformer is this? What kind of transformer is this one? Guys, what kind of transformer is this? You are getting an output voltage which is greater than primary voltage. This
Step
is
up.
step, right? Okay, quickly note it down and then step. This was a very simple question, right? Quickly note it down and then we yes, guys. Whenever you have noted it down, select it. I
The
have
1 minute.
uh, we have one to start with that. Let's start the last bit of questions from this. Start here. Noted, guys. Yes, guys, when you guys have get still.
Yes, done.
Yeah. So how is the weather there, right? Don't forget to have some water. This is the winter season. We usually forget to have some water. That is that we need to have. Okay, so let us do this question, right? The last question I will leave it. Okay, so what are the things which are transformer consisting of 300 turns, right? So primary coil, you are given the number of turns, you are given the number of turns in the primary coil. This is 300 and 150 turns. So you are also given the number of turns in the secondary coil, 150. And then in the secondary gives output power, right? So you are getting output power which is 2.0 kilowatt, right? Which is how much? 2200 watts. And if the current in the secondary coil, so current in the secondary coil is 10 amperes, right? Then the input voltage and current in the primary coil are, right? So what we can calculate? So we know that this is the power and the current. So what would be the voltage in the secondary coil? Voltage in the secondary coil would be how much? So that would be power in the secondary coil and then I by P. I by P or P by I? Yes, P by I, right? Because P is VI. So, yes. So this would be the voltage. So 20, 110. So this is 220. So primary voltage now V, number of turns V, and this is 100% efficient transfer, right? Whenever the efficiency is not given, so we assume that this is 100% efficient transfer. So what do we have? So we can calculate, we know that Vp by Vs, that is Np by Ns. Right, so this Vp, we don't, let's say this is X, this is Vs and Np by Ns. This would be how much? Vs is 220 and this is 300 and divided by 150. So this is 2. This is 450. This is the voltage in the primary. And similarly, we know that what is the power. So P output, this is equal to P input. So P S I S, that is equal to PPI. We want to calculate IP, right? IP SIS divided by. So how much is this thing? VS S is 20. IS is how much? IS is 10, right? And this is VP is how much? So this would be 2 and this is 5. Current would be 5 amps. And we can also calculate. Is it clear, guys? Is it clear? Is it clear, everyone? Yes. Arif, clear?
Yes, clear.
Yeah. So what kind of transformer is this? What kind of transformer is this?
So step down.
Step down. Good. So primary is 440, secondary is 240.
Yes, sir.
So step down. Yes, correct. Yeah, you guys note it down. Then we'll do the last question, and then last one I will leave it to you guys, and then we'll move on to electromagnetic. Yeah, whenever you guys have noted that. Yes, noted, guys. Then
Sir. Yes, sir. Done.
then let us quickly do the last question. And guys, okay, so a power transmission line feeds input power at, we know that what is primary is step down transformer with its primary winding having, we know that what is primary winding, 4,000 turns. The output power is delivered at 30, right? So output power is 30 volt. And if the current in the primary of the transformer is 5 ampere, current in primary is 5 ampere, and its efficiency is 90%. Efficiency is 90%. This is percentage efficiency, right? The output current would be. So we have to calculate what is the output current. This is right. So we know that what is the efficiency, right? So we can, this is in the percentage efficiency. So we can calculate efficiency. That would be 90 by 100, which is 0. Right. And then from this thing, what we can calculate? So we know that efficiency is output power divided by input power. Right, so this is ESIS divided by, we have VPI, and this is eta. So why this number of turns that is given, that is right? So this would be how much? Eta is 0.9, right? PS is 230. IS we want, and VP is 2300, and IP is 5x. Right. So if we connect this, calculate this IS, so IS is 2300 by 0.9, and then 230, and yeah, so this is 10. This cancels out this one. This is 45. What was the need of this thing? So is it clear, guys? Is it clear? Yes. Is it clear, everyone? Yes. Is it clear, guys? Oh, so we have 5 chats. Is wave optics coming in JEE? Output input. Yeah, wave optics is there, right? Wave optics is there in JEE. Some portions have been omitted, but wave optics is have interference and those that is there is diffraction. That is there. Yeah, but yeah, so you guys focus on your 11th part, and because the next week you guys are having this J part, right? So prepare some portions from 11th class, and then complete this first book, and then please also do some portions of atoms and nuclei. That would be enough. That would be enough. That important chapters for J, right? important ones are in 11th portion, those force and laws of motion. That is very important, right? So the first chapter is not that important, dimensional math.
In
Second,
11th, the last also this one, right? Rotation, motion, and all.
yes, the last part. Yeah. So from
The last
yeah, your voice broke in the middle actually.
rotational motion and all, right?
Yes, mostly in your voice is breaking, sorry. So from the 11th portion, we have these three, four. Fifth rotational is not that important. Rotational one is not that important. So three, four, five. And sixth one is the rotational. Seventh one is the gravitational. Rotational is not that important. So seven. And then you have this mechanical properties of solid and then mechanical properties of fluids. So from fluids is Newton's law. Right? But sorry, but yeah, so from the second book of 11th part, electromagnetic waves, oscillation, and thermodynamics, yes, that's not that. Yeah, kinematics, oscillation, kinematics, electromagnetic waves, and then yeah, those stress and strain parts. So that is 11th portion, and then from 12th portion, the first book, and then atoms and nuclei. And yeah, so that would be quite enough. That would be quite enough. Yes, that is all action. Basic data. Oh, sorry. Yes, Tarif, can you hear me now?
Yes, sir.
Yeah. So what were you saying? What were you saying?
Yes, in 11th and for the 11th topics, the last rotation, motion, and all, right? I saw it repeated in many questions.
Yeah, rotational mechanics. Yeah, rotational one is not that much. So you were talking about the sixth chapter, system of
Yes, sir.
particles.
Yes,
No, no,
sir.
no. That one is not that much. That one is quite a chapter, right? And it is not that.
Yes, sir. Can you write down the important chapters to revise so we can focus on it?
Yes. So the chapters from 11, right? That would be second chapter, third, fourth, fifth, seventh, and then eighth, right? And then mechanical properties of yes, that is also ninth, tenth, and then thermodynamics is not that important. Okay. Yeah, but partition energy then those. So yeah, but that would be enough. And then last one is what? So waves and oscillation. What is that chapter? Last. Right? From 11th and from 12th, first, let's say, right, first book, 1 to 7. And then you can leave those ray optics and what wave optics, and then 8, 9, 10. This would be quite all these chapters. And now only 15, right? Okay, not you guys. So you guys, what you guys do is that primarily focus on the right, focus on the board segment, and then you concentrate on then you focus on this. Boards are more important. So in priority list, Boards are more important than JEE part. And then after you have cleared your boards, then it is then JEE part is there, right? Primarily focus on this. Okay, so did you guys note down this part? Note it.
Yes, sir.
Then let us start. Is NCRT formula enough? AEW, AEW is enough. So some topics have been omitted, right? Oh yeah, so NCRT for atoms and nuclei and yeah, all those portions. NCRT would be enough, but yeah, for the first four chapters that we have got, right? Some portions were not there. For example, the solid sphere was not there, and then hollow sphere was not there, and all these things so were not there. So yeah, we have to add some portions, right? Which have been omitted in the NCERT. NCERT is enough, but the extra things are there. The extra things are there, which have been omitted in the CBSE syllabus, but that are there in the JEE. That we should, yeah, that we should also. Okay, so the next chapter, the last question, I will leave it to you guys, right? Last question. Number of turns are given, right? Current is given and they are asking secondary current. That is okay. If I start the next chapter, right? Okay. Yeah. So I will back in right. One, give me one. Yes, I'm back, guys. Okay, so in the previous chapters, what did we learn? That the charges were moving with a constant velocity, right? So that produced a current, and yeah, and then we talked about the stationary charges, right? In electric charges and field and electric potential, and then we talked about moving charges. But those charges were moving with a constant velocity. Now, whenever the charges accelerates, right, so they then produce these electromagnetic waves, right? So then in this chapter, right, we also understood about this displacement current, right? So between the capacitors, right, between the capacitors, there's no movement of the charges, right? Charges are not moving. But then we also get the current in the so then we also get the current between those plates. So those are called the displacement currents, right? And yeah, we got the value of that displacement current as well, right? So what was the value? And that current was produced due to the change in electric flux, right? So what was that? So this we had this Ampere circuit law, right? Or this was what? P dot dl was mu naught I in Q. So this I was the conventional current. But Maxwell corrected this thing, right? So then the Maxwell correction was what? This was mu naught IC plus IT, right? This was the displacement current. And how much was this thing? So this displacement current was epsilon naught, right? So epsilon naught d phi E by dt, right? This was the displacement current. So this is the displacement current. And then how these electromagnetic, right? So if so, this was the first thing that we learned. And then secondly, we learned about the electromagnetic wave propagation. So we had this, let's say this is the Z direction, this is Y direction, and this is the X direction. And the waves are propagating, let's say, in Z direction. So we will have this magnetic field, right? This is the magnetic field, and this is moving in Z direction. This is magnetic field, and then we have this electric field as well. Right. So this is the electric, and this is so this is moving in y direction, and this is b naught and sine kz minus omega t, and this is in x direction, and this is e naught and sine kz minus omega t. So if I write the wave as kz minus omega t, if I write sine kz minus omega t, or sine omega t minus kz, which means that the waves are propagating through positive z direction. And if I'm writing this wave, so kz plus omega t, this is in negative z direction, right? So this is the propagation of wave. And the direction of propagation, how do we calculate that? So direction of propagation, this is given by E cross V. So this will give you the direction of propagation. Okay, so we can check from here as well. Right, we can check from here as well that electric field is in what direction? E hat is I hat, X direction, and V is what direction? J direction. So the propagation would be E in Y. Yeah, magnetic field in Y direction. So that is Y J hat. So if we calculate the propagation, E hat cross B hat. So that would be what? I hat cross J hat. So what is this thing? I cross J, if we use the circular property. So Ij is K hat. So that is why the propagation would be in K hat direction, in Z direction. Yes, positive K hat direction, so positive Z direction. So that is why, and then the peaks are also related, right? So peaks are related, right? So this is related by speed in vacuum. So how much is this? This is E naught by V naught. So this is C is E naught by V. This is one thing. Okay. And there's one more thing which is also important, that the speed of wave, that would be how much? This is V, and this is omega by K. Right. This is one thing. And we also know that what is so this C is also related with the permittivity, right? This is related by C square is 1 by mu naught and epsilon. Or if I will only write C, so that would be simply this. And in medium, so this is in vacuum, right? In medium, what is that? So in medium, this V would be simply 1 by, let's write it this way, mu and epsilon, right? So if I write this mu in terms of relative permittivity, so this would be mu r and mu naught, and this would be how much? This would be epsilon r and epsilon naught, right? So let us write it separately, right? So this would be 1 by epsilon naught and mu naught, and this is 1 by root mu r and epsilon naught. So how much is this? Right. So this is V equals to, this is C, and by mu r and epsilon. So if I take this thing in this side and this thing in this side of mu r and epsilon r, this would be how much? C by V. So what is this thing? Guys, what is this thing? What is this thing? Yes, guys, what is this thing? Frequency. Frequency nu is C by V. This is C by lambda. C by lambda is frequency, right? So C by V, velocity of light in air, velocity of light in medium. So that is refractive index. Yes, the refractive index. And this is absolute refractive. Right. So in this way, we can also calculate. So from relative permittivity and relative permittivity and relative permeability, we can calculate the refractive index. Right. And then we also have the energy density of electromagnetic field, right? And this is U total. This is how much? This is half epsilon naught E naught square, right? And this is equal to U U E, or this is equal to U. So U total is UP plus UP, right? From electric field part, and this is magnetic. So this is how the energy density is, right? And we have this electric field energy density. This is equal to half epsilon naught and E RMS square, and UP. This is half epsilon naught and epsilon. This is V naught square RMS square by. So this is these are the things, and the last thing is intensity. Intensity is this is half and C epsilon naught and E naught. These are the things that we have to do. Okay, so these are all about this EM waves that we have to remember, and then we can do all the other questions, right? Please note down these parts, and then we will do some questions. Please note down these. Yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys want me to scroll down, please tell.
Yes, sir, can you scroll down?
Oh, up. Okay. So is it uh, is it okay? Is it okay, Chavez? Done. Chavez. Yeah, Chavez is putting it down. I want. Whenever you have noted Chavez, please tell. Chavez noted. Then Chavez. Then, then yeah, whenever you guys want me to scroll down, please tell. Then, Tarif noted.
Yes, certainly.
Okay, then please. Yes, done, guys.
Yes, certainly.
Done. Okay. So, yeah, these are the things that we have to remember. So, we'll do the questions in the next slide. Okay, whenever you guys have it, still, whenever it is complete. Whenever you guys have completed, please do. Yes, done everyone?
Yes,
Tariq,
sir. Done.
done. Okay, so yeah, we'll stop it here, and I guess you guys will be having your JEE exams, right? So all the best for that, all the very, very best, and yeah, and whatever you have prepared, just focus on that, right? Don't buy new things, and yeah, and also prepare for the CBSE books, right? So Allah Hafiz, guys. Allah Hafiz. See you in the next class, guys. Allah Hafiz.